Hello, ladies and gentlemen. This video is just to give you a little bit of a geometry overview of some of the major things that a person would want to remember from that class of geometry that you took. Okay, some of the big things that are widely applied in many different types of questions or branches of mathematics. So today in your notes, if you would just write down some of these major topics, and then again, we'll take a look at some questions dealing with them in days to come here. So our geometry review or our overview here begins with our right triangle relationships. Right triangle relationships, remember, hinge on the idea that right triangles have 90-degree angle in the corner. So it would look something like this. So this would be your 90-degree angle. It might be marked with this little box, right? Remember that, 90 degrees. And then we have two legs on every right triangle as well as a hypotenuse. The hypotenuse is always the longest side across from the 90-degree corner. So notice the 90 degrees is here. This is the hypotenuse of that triangle. Now, when you have this right triangle, there are many relationships that the sides and angles have. For example, if you know two sides and you want to find the third side, you can use the Pythagorean theorem, which says a squared plus b squared equals c squared. Remember that a and b are the legs, the two non-hypotenuse sides, right? And C is the hypotenuse itself. So the leg squared plus the leg squared will equal the hypotenuse squared. And then we could plug numbers in and solve for any X's or C's or A's that we might be missing there using that relationship. So the Pythagorean theorem works when you have two sides and you're trying to find a third. But what if you only have one side and maybe an angle is given to you, like 34 degrees or 20 degrees? Then you want to turn to your trigonometry relationships. So your trig ratios, otherwise known as SOHCAHTOA probably for many of you, your trig ratios depend on the acute angle given to you in the triangle. So if this angle is 34 degrees, I could use that angle to help me find other sides as long as I have some other information about my triangles. The way trigonometry works is you always have to have an acute angle there, and you pretend that you're standing at it. So if you are here, there's an opposite side from me, there's an adjacent side to me, and then of course there's still the hypotenuse of the triangle. So the trig ratios work like this, or look like this. This is the sine ratio. The sine of the angle, that's called theta, but it's a representation of angle. Sine of angle equals opposite side over hypotenuse side. So the sine of any angle will be the ratio of the opposite side of it, or in reference to it, right, over the hypotenuse. And then cosine was adjacent over hypotenuse, and then tangent was opposite over adjacent. Now all of these depend on you having this acute angle that you're standing at. Because of course, if you don't know what the acute angle is that you're standing at, you won't be able to identify which side is opposite you and which side is adjacent to you. And then, of course, then how, once we set up these formulas, do we go about solving for a missing side? Those are all things we'll need to take a look at as we review. Some other geometry things that you might want to get into your notes. Area and perimeter formulas that are pretty important. Things that transcend all the others, if you will. The idea of perimeter first. Perimeter is the distance around the outside of a figure. So you add up all the sides, no matter what that shape is, octagon, pentagon, hexagon, even like a weird shape that doesn't even have a special name, okay? All the sides just get added together and that makes up the perimeter. The circumference is what we call perimeter for a circle. So it's the distance around the outside of a circle. So that would be my circumference, would be the distance here around the outside edge. So that's found by finding 2 pi r, or 2 times 3.14 times radius. But oftentimes it's just okay if you leave your answers in terms of pi. That means not even worrying about the pi, just leave that as part of a label in your answer. Now area is a little different than perimeter. Area is the square units inside of a figure. So rather than worry about what's around the outside, we'd be finding how much space is actually being taken up on the inside. So it's measured in square units inside of a figure. And the key ones to know, area of a triangle, 1/2 base times height. You may have also learned it as base times height divided by 2. Area of a rectangle, base times height. Sometimes we say length times width. Area of a parallelogram is also base times height. Now watch out because a parallelogram is kind of slanted, right? And so the base would be down here, but the height has to be a straight up and down measurement. That's what height means. So you might have to know some more pieces of information about your picture. Area of a trapezoid is kind of an interesting one. You see that a little bit more often on these higher level tests and such. So 1/2 height times the times the bases added together, what you would get when you add those bases together. So 1/2 height times base 1 plus base 2. Now remember, with a trapezoid, the bases are the two sides that are parallel. Base 1, base 2, it doesn't matter which one you do, but you need to make sure you add them together. And then area of a circle, very close to circumference. There's a 2 in it, there's a pi in it, there's an r in it, but it's pi r squared because now we're talking about area. So these are the big things in terms of area and perimeter we want to make sure we remember as well. Now, other facts that are really important to know. For example, a triangle has interior angles that add up to 180 degrees. So all the angles in any triangle will add up to make 180. Whereas a quadrilateral, a four-sided shape, has angles that add up to 360 degrees. Now notice triangle had 3 sides, quadrilateral had 4 sides. The pattern is that you just keep adding 180 degrees to the total as you go along for other sides, or like a pentagon, an octagon, and so on. Now, parallelograms, we kind of alluded to this just a minute ago. It's another important fact to know that parallelograms have opposite angles that are equal and consecutive angles that are supplementary. Remember, supplementary means 180 degrees is what you get when you add the angles together. You may confuse this with the word complementary, which means the angles add to make 90 degrees. Consecutive means that they're in a row or side by side. So we have angles that are congruent that are opposite each other, but we also have angles next to each other that are making 180. Other things that you might see, congruent. Congruent, remember, means equal measurements. In terms of shapes, that would mean all the sides and angles that are the same. The symbol for congruent is that equal sign with a little squiggle above it, right? That's a symbol that means the shapes are equal in length or measure for all their angles, or you can say an angle is congruent to another angle. Similar, same shape, but different sizes. So you might have one enlarged version of a smaller shape. So you're going to use ratios or a scale factor to solve or compare to find missing sides. The basic symbol for similar is just that little squiggle there. That would be the same thing as on top of the congruent sign. Now, midpoint is just the way it sounds. It's a point in the middle. Well, how do you find that? It's no different than finding an average. It's the average of 2 points. It's that spot in the middle. So you may have memorized it or seen it like this formula, where you add the x's of 2 points divided by 2, add the y of 2 points divided by 2, but it's more easily remembered as just being the average of 2 points. So add 2 points together and divide them by 2. So if one point is 1, 3, and the other point is 5, let's say 5. If I add these 2 points together, 1 plus 5 is 6, divided by 2, 3. 3 plus the 5 makes 8, divided by 2, 4. The midpoint would be 3, 4. I added the x's divided by 2, added the y's divided by 2. This is the midpoint. Okay, that's just the average of the 2 points. Add them together, divided by 2. So these are the basic overview ideas that you're going to see most often, things that you need to remember as we carry on from one math course to another, or you're assessed on these things, okay? I want to thank you for taking these things into your notes, and we'll take a look at some sample questions in a bit. Kincaid out.